All right, there's a few questions on homework question number 5 in module 13. Um, and I just kind of wanted to help separate the different questions. And so this question is telling us, okay, ammonia is consumed at, 1.4 times 10 to the minus 5 molar per second. Calculate the relative reaction rate. And the questions that we did in class, and I kind of, again, I don't really like a few of these early questions in Top Hat because they're asking you for the average reaction rate, not the relative rate, because the relative rate is what we were doing in class. The relative rate, for example, is ammonia is being consumed at 1.4 times 10 to the minus 5 molar per second. We're reporting that rate relative to ammonia. And if we did these calculations in class, right, we saw that right, for example, I can convert this rate to oxygen because I know from the balanced chemical equation, right, 4 molar ammonia, um, 5 molar oxygen, so 5 over 4. The rate for oxygen was, I think, like 1.75 times 10 to the minus 5 molar per second. So that would be the relative rate of this reaction with respect to oxygen, right? Oxygen's being consumed um, at this rate. And we could do the same thing to calculate the relative rate for nitric oxide and water as well. Um, NO, right, nitrogen monoxide, would be the same as ammonia. So that would be 1.4 times 10 to the minus 5, right, that it's being produced. And for the water, um, right, for the water, we would say, well, 4 moles of this and 6 moles of water. So 4 times 6, water is going to be produced at about 2.1 times 10 to the minus 5 molar per second. So these are all relative rates. They are relative to one specific species in the reaction. And you can notice, right, they're all different. And that's where it can get a little bit confusing because if we look at this, right, all of these rates are different except for obviously these two because they have the same coefficient. So these are all relative rates. So sometimes, and more often what we report is the average rate because I don't see this unless I'm looking just at oxygen or just at ammonia. So the relative rate, we're essentially going to set the coefficient equal to 1. Because if we look at this, right, this coefficient of 4 means ammonia is reacting 4 times faster. This coefficient of 5 means oxygen's reacting 5 times faster. So to find the average rate, all we need to do is take the relative rate for one species in the reaction and divide by its coefficient. So, for example, I have ammonia, right? I know ammonia reacts at 1.4 times 10 to the minus 5 molar per second. And the coefficient in front of ammonia is 4. All right, so I'm going to multiply that by 1 over 4, basically dividing that by 4 to get the average rate of the reaction. So I divide that by 4, and the average reaction rate comes out to be 3.5 times 10 to the minus 6 molar per second. We could do the same thing for oxygen, and we would get the same answer, right? So oxygen, we see oxygen react at 1.75 times 10 to the minus 5 molar per second. The average rate, right? We would set that equal to 1. We would divide by the coefficient, so 1 over 5. I divide 1.75 by 5. And I get 3.5 times 10 to the minus 6 molar per second. So that's how we find the average reaction rate. If we know the relative reaction rate for anything in the reaction, we would just divide by its coefficient, right, to turn that into the average rate. So looking at the reaction overall, right, our rate law that we write for this reaction, we would come up with the average reaction rate. These first four rates here are all relative to one specific species in the reaction.